Hi everyone, this is Mrs. Kmack, and today we are doing Lesson 15, Equations of Graphs of Proportional Relationships Involving Fractions. Your essential question is, how can we use tables and graphs to interpret what the data or the numbers mean? So what do the numbers mean on a graph or table? Okay, we're going to start with this example of Mother's 10K race. Sam's mom has entered a 10K. Sam and his family want to show their support of their mother, but they need to figure out where they should go along the race course. They also need to determine how long it will take her to run the race so that they will know where to meet her at the finish line. Previously, his mother ran a 5K with a time of 1.5 hours. I'm going to stop there. A lot of times, when you're given a problem, I tell you to be reasonable. So I just want to put a quick disclaimer on here. If you or someone you know runs, that's actually not very realistic. But in math problems, when they give us those numbers, we kind of have to go with it. So it says that she ran a 5K and it took her an hour and a half. They're assuming that Sam's mother is going to run at the same rate as the previous race. So they're saying we know that when she ran a 5K, it took her an hour and a half. So let's use that ratio. Remember, ratio compares to quantities or amounts. We're going to use that to figure out what her pace would be for this 10K race. Okay, so this is now a 10K instead of a 5K. All right, let's create the table, and then we're going to talk about the graph. If I look at the graph, I see these numbers: 1 hour, 2 hours, 3 hours, 4 hours. I'm also going to be thinking about what happens in between those, since we already know that this talks about 1.5 hours. Okay, for the time, let's try to include all these numbers here from 0 to 4. So let's start out with 0. So 0 hours. And then let's go up by half hours, since I see that we want to get to 1.5. So half an hour, 1 hour, 1.5, 2, 2.5. And then I'm actually going to have us squeeze in there 3. Let's go ahead and put 3. I do want all of those because I want you to see the order. Okay, the only one they give us is 5 kilometers. So the distance for 5 kilometers is going to be right here at 1.5 hours. So how can we figure out what the rest of those would be? How can we figure out what the rest of those would be? Well, hopefully you know that in 0 hours that she would run 0 kilometers. She hasn't gone anywhere. Okay, if you don't have your calculator out, you need it out now. You need it out now. Okay, so I know that in 1.5 hours, that's 5. So what we can do is we can figure out what the unit rate would be. How far does she go per hour? Per hour. To do per hour, you need 5 divided by 1.5. 5 divided by 1.5. Okay, go ahead and type that in your calculator. And if you did it as a decimal, you got some repeating number. But if you did it as a fraction, you would have gotten a mixed number. You should have gotten 3.3 repeating, which is 3 1/3. So that's the unit rate. That's right here. So each hour she can run 3 1/3 kilometers. 3 1/3 kilometers. Okay, so how can we figure out the rest of them? Well, I know that if 1 hour is 3 1/3, then 2 hours, let's talk about right here, that would be double that. So we can double that, and it's 6 2/3, or 6.666666 repeating forever and ever. Okay, and then now what I want you to do is, if 1 hour is 3 1/3, well, what would half an hour be? Hopefully you can realize that it's half of whatever 3 1/3 is. Go ahead and try that one on your own. Okay, did you get 1 2/3? So each half hour is 1 2/3. And then go ahead and try 2.5 hours. Okay, pause it if you need to. And you should get 8 1/3. 8 1/3. Okay, the multiplier from the hours to the distance is 3 1/3. 3 1/3. So if you're confused, and slow down and try them again. You're multiplying the hours by 3 1/3. Okay, and then go ahead and figure out what the last one would be. 3 hours would take, that should be a special number that you are paying attention to, because That's how long her race is. So we know that in 3 hours, that's how long it takes her to run 10 kilometers. Okay, go ahead and graph the points. If you're not sure where to start, graph 0, 0, graph 3, 10, and then try this one. Try 1.5 and 5. Okay, you might need to look though because 1.5 isn't on here, but it's halfway between 1. I want you to pause it. I want you to graph as many of these as possible and see if it makes a straight line. Remember, these are not going to be exact. These are not going to be exact. See, this is 1.5, and this is 5 right in between. This is half an hour. Plus, a lot of the numbers are not whole numbers. So yeah, it looks like it is a straight line. And then if you look at your first question, your workbook, sorry, I didn't really go through those nicely. What are some specific things you notice? You should notice that it's proportional. And goes through the origin. And is a straight line. What is the connection between the table and the graph? Well, really what it's just saying is the time in hours and distance in kilometers can be graphed. That's all that we did. We just said, okay, we can take these points and we can make a graph of them. Here's 3 hours and 10 minutes, or sorry, 10 kilometers. Again, I showed you 1.5 hours, 5 kilometers. So you do see that through 0, 0, it does make a straight line. You can use a straight edge to make sure that yours is directly in line. Okay, so what does 2, 6 and 2/3 means? Go ahead, pause it in context of this problem. I know you've heard me say that phrase over and over and over. You're writing a sentence that compares 2 and 6 and 2/3 to this problem right here. Go ahead, pause it and write a sentence, a 7th grade sentence about what do these numbers mean. Okay, when you unpause it, go ahead and see if you have something similar to me. You don't have to change it, but I just want to make sure you have something similar. You can have in 2 hours, she can run 6 and 2/3 kilometers. Okay, and just a quick thing here, 6 and 2/3. It looks like this, the mixed number and the fraction. Okay, or you can say it takes her 2 hours to run 6 and 2/3 kilometers. If she's going to run 6 and 2/3 kilometers, it will take her 2 hours, something along those lines. Okay, that's example 1. Go ahead and turn your page to example 2. We're on page 61 here. All right, after taking a cooking class, you decide to try out a new cooking skill by preparing a meal for your family. You have chosen a recipe that uses gourmet mushrooms as the main ingredient. Okay, that word gourmet makes me think might be expensive, and when we read here, you'll see what I'm talking about. Using the graph below, complete the table of values and answer the following questions. Well, this one actually got us started here, so I can actually see a lot of the values here. 0, 0 is right here. All that means is if I don't buy any mushrooms, I don't pay any money. 1 comma what? I don't know what the unit rate is. They only give me fractions. Half of a pound is $4. I know that you are smart enough to do this. So right now, think in your head, okay, if half of a pound is $4, then how much would a whole pound be? It's also on the graph. So look on the graph to figure out how much 1 pound of mushrooms would cost. Okay, if you already did that, unpause it, and did you get $8? Each pound is $8, so that's why half a pound would be half of that, $4. So our multiplier from the pounds to the dollars is 8 times 8. Now this one says, what if it's $16? Well, we can do the inverse to go to the weight. So we can do 16, we can take an eighth of that, or that's the same as dividing by 8. So now figure out how much in pounds I would get if I spent $16 at the store. Pause it and get that figured out right now. Okay, did you get 2 pounds? Hopefully that one wasn't too bad. Okay, I want you to pause this and I want you to do the first question, the second question, the third question, and the fourth one. Okay, pause it and do those questions. I'm going to keep talking those, so please make sure that you pause it right now and try those out. Okay, for the first one, the answer is yes, because it is a straight line through the origin. You should be a pro at that by now. Okay, and then what is the unit rate, or what is the cost per pound? Please make sure you write it like this. It's okay, whatever you have. If you just have 8, that's fine, but write it like this. I want you to see it as $8 per pound. There's other ways to write it too. You could have this. You could have just the number 8, and you could have LB, which stands for pounds. It's good to see it represented different ways so that you understand the different representations that mean the same thing. Okay, how'd you do with your equation? Did you know that it was y equals kx, and then we already know what k is, the constant of proportionality? Hopefully, that's that magic number that we always talk about. So y equals 8x. I even want you to write it one more way. The cost is $8 times the weight. That means if I buy 1 pound, I would multiply by $8, or multiply by 8, and it's $8 total. If I bought 2 pounds, like here, times 8, that would give me $16 for the cost. So it's just good to see it with different letters so you can think about it in terms of cost and weight. Okay, what order pair represents the unit rate? Well, we know it's 1, right? So the cost of 1 is 8. That's all there is to that one. And then what does 2 comma 16 mean in context of this problem? So if you haven't been paying attention, hopefully you're seeing that phrase in context of this problem. Go ahead and write down what 2 comma 16 means. There's more than one way you could write it. And like I said, pause it if you need to and write it, then unpause it. If I buy 2 pounds of gourmet mushrooms, it will cost $16. You could also say if I have $16, I can buy 2 pounds of mushrooms. Okay, this one, I want you to think about what this one means and what this one means. You can even use your equation for those. If you could spend $10 on mushrooms, how many pounds could you buy? I'm actually going to go ahead and copy this equation here, and I'm going to copy it here. Okay, go ahead and solve both of those. The second one says, what would be the cost of 30 pounds of mushrooms? Go ahead and solve both of those, and then unpause it and see how you did. Okay, if you could spend $10, that's the cost. $10 is the cost. So what would be the weight? You need to do 10 divided by 8 to give you the weight. When you did that, hopefully you got 1.25 or 1 1/4 pounds of mushrooms. Those are the same numbers. Okay, and if I were to buy 30 pounds of mushrooms, holy smokes, that's a lot. Hopefully I'm a restaurant owner, because that would be a ton of mushrooms, and that would be actually a lot of money, because $8 for a pound of mushrooms is a lot. These are gourmet mushrooms. So go ahead and plug in 30 for the weight. So 8 times 30 will give me my cost, and I like that one because I don't have to divide. It's $240. Okay, and that is a wrap on lesson 15. See you in class.